welcome to 6.7, Congruent Triangles. Okay, so today's lesson is going to give us two new ways to prove triangles are congruent. So I really feel like you should be able to do the proofs for these without looking at the book at this point, because you've already learned the side angle side and the angle side angle in the previous lesson. So if you kind of remember those proofs, these should not be that difficult anymore. Okay, just unless you're struggling with proofs in general, which is a struggle, but hopefully they're starting to seem easier at this point. Okay, so the first theorem is side angle angle. Okay, so if two angles of a triangle and the side opposite one of the two angles are congruent to the corresponding angles inside of another triangle, then the two triangles are congruent. So let's look at what all those words mean with pictures. Okay, so here I have two triangles. Let's look at the one on the right first. Well, first let's look what we have. We have side angle angle, which, remember, if I have two angles congruent, I already automatically know my third angle is congruent. But having just one side be congruent and two angles, doesn't matter what side. So here I have AC is congruent, so that's my side, and then angle angle would be angle A, angle B. But it could just as easily be segment CB. That would be a side, and then have angle XZ be congruent. So that would be side, and then my angle would be BA, angle angle. So it doesn't matter as long as I have one that is not included. If it's included, I have angle side angle. So this is different, but yet that means all of my parts, all the congruent parts are congruent. I'm sorry, the corresponding parts are congruent. Of course, congruent parts are congruent. Corresponding parts are congruent. Okay, so this one is to a very specific kind of triangle. The Isosceles Triangle Theorem says that an isosceles triangle with two base angles are congruent. Alright, so if I have two sides that are congruent, I have an isosceles, then that means the opposite angles are also congruent. So let's look at that. This has to do with just angles and sides in one triangle, not two triangles being congruent. So if you look, it looks like I have two triangles now, right? This is kind of the picture that will help prove this for you. This would be an auxiliary line. If I were going to write the proof, I would just draw this line. So now I know that these two are congruent. Now don't I have two right angles? All right angles are congruent. And now I have the opposite angles of that congruent side. Those angles are congruent. So let's look at the proof for that real quick. Okay, so my given is that I have an isosceles triangle and then I have two sides congruent. I'm going to go ahead and make a auxiliary ray that bisects angle X, which now means I have two angles that are congruent. Remember, bisectors means exactly in half, which is the definition of an angle bisector. And then I know that auxiliary ray that I made is congruent to itself, right? What property is that? Hopefully you remember that that's reflexive. And then I have the whole triangle is congruent to the other side of the triangle, but remember what I'm trying to prove, okay? Oh, that is what I'm trying to prove, my bad. I am trying to prove that those two triangles are congruent with side angle side, and that, oh, I am trying to prove the theorem. See, I'm sorry, I got mixed up there for a second. So once I prove those two triangles are congruent, all the corresponding parts of the congruent triangles are congruent. So now those opposite angles, like the theorem says, are now congruent. Okay, definition of congruent triangles. Okay, so sorry if I was talking in circles on that last slide. I'll, if you have questions about that, that's what your whisk is for. Okay, so next theorem, if two angles of a triangle are congruent, then the sides opposite those angles are congruent, and then the triangle is an isosceles triangle. So if you notice, this is opposite theorem 620, right? I'm now, instead of starting with sides, I'm starting with the angles. and I can work kind of backwards there. And the last theorem of the day is a triangle is an equilateral if and only if it is equiangular. So this is a biconditional statement, remember? So if it's equiangular, the triangle is an equilateral. Okay, so remember, when you have biconditional, you can read that forwards or backwards. Just a reminder, I only went over one proof, but there is another, let's see, I read one to you, and there's 3 more in your book in this section. I'm not going to say every time review the proofs. It's automatically expected that you're going to look at your book. Okay, these PowerPoints are just highlights, the notes, so to speak, of the section, but I do expect you to look this over. I know some of you are not, and then you are not having success later on with the exercises. So please, please, please read your book. That's why your parents bought it for you. Okay, so the whisk summary. Well, I want you to rewrite in your own words, in paragraph form, okay, the proof of side angle angle. Now, there is one that you can look at in your book, but it's the statement reasons. It's the T-chart version. I want you to tell me in a paragraph. Okay, and it really isn't a really long thing to write. In fact, I think I only had, actually think I only had 2 sentences. So you can be brief and thorough at the same time. Alright, so look forward to your emails on that, and I will see you in class.